Today's lesson is going to talk about the different conic sections and what they are. There's not much that you really need to write down in these notes, but then when you get done, your homework is to kind of recap the notes and put the four pictures together, and I'll explain that at the end. So we keep talking about how there's four conic sections. So what are these conic sections? Well, if you have two cones that are stacked on top of each other with the point of the cone touching, and you have different intersections of a plane in that cone, you can create different shapes. So on this first one, you have an intersecting plane that cuts through only one side of the cone. And when that happens, you create this shape right here called a parabola. This shape in here. Okay? When the intersecting plane is perpendicular to this x-axis, then you're going to create a perfect circle. And there's all different places we can move this plane, so it's going to create different sizes, but that's what the shape is. If the intersecting plane cuts through both sides of the cone, but it's not perpendicular like the circle, then you're creating what we call an ellipse. The final shape is when a plane cuts through both of the cones. So before, it's a parabola, circle, and ellipse, it's only cutting through one of them. But when it cuts through both of them, it creates this little U here and this little U here, which then creates what we call a hyperbola. Okay, so each one of these conic sections we can define and we can plot and we can graph, and there's all sorts of important information and facts about these, and all of them are second degree functions, which means in all of these you're going to have the highest degree is 2. It can't be less, it can't be more. The highest degree is going to be 2. All right, now that we've seen why we have those conic sections, let's talk about a little of the details of each of them. So in the first one we have a circle, and that's what we just reviewed. And I picked that on purpose because it was good timing with the seniors and you had seen it in geometry. But in the circle you've got your center right here, which is HK, your radius, and then you could have a point on a circle, and that's center or located somewhere in your coordinate plane on that with the x and y axis. And you could calculate that radius if you wanted to by using that modified distance formula that hopefully you got right on your quiz. So that's a circle, and we notice the center is found by the point H and K. Now you're going to notice that H and K appear a lot in these. You'll also notice that the highest degree is 2, right? All right, a parabola. We did parabolas first semester, and we're actually going to review them next because parabolas are really important and come up a lot. The other shapes aren't going to come up as much, or shape's not the right word. Conic sections are not going to come up as much, so we're not going to put as much emphasis on it, and we're online and we have a lack of time. But this is what we're going to look at next. But we've got a parabola. Now there's some things about the parabola that you do know. You should know, or hopefully remember, this vertex is the point down at the bottom. So it's the kind of the turning point. Now this parabola happens to be going up, so at that point the parabola is going up on either side. It could also be opening down, and at that point it would be going down on either side. We do know about the axis of symmetry. The axis of symmetry cuts the parabola in half. If we were to fold the parabola on that axis of symmetry, everything would match up perfectly. All the points would line up. Now, what might be new to you is this point called the focus, and the focus is located on the axis of symmetry, but inside of the parabola. So in this one, it's above the vertex because the parabola is opening up. But if we flipped it and the parabola is opening down, then the focus would be down here, so it's inside of the parabola. But the focus is right there. Now, whatever the distance is between the focus and the vertex, lost my pen. Okay, whatever the distance is between the focus and the vertex, there's the same distance between the vertex and this line that we call the directrix. Okay, so those are some important features of a parabola. Okay, so now we've got another shape. This one is the, whoa, hold on. It's your hyperbola. Hyperbola is kind of a crazy shape. Now, as you're looking at it, it looks a little overwhelming, but if you start to focus on it for a second, you'll notice that in between the two equations is a minus sign, and that's important because the next shape is not going to have that. On the first one, X is first. So when we have the X first, we're going to have what we call a horizontal transverse axis. So the parabola is going to run, I said that wrong, the hyperbola is going to cross over the x-axis, okay, the horizontal line. Now compare that to the second one. The second one, y is going first instead of x is going first, and then we call that, it's got a vertical transverse axis, and it's going to cross over the y-axis. Okay? Now, on my screen, these red dashed lines, they're not actually part of the graph. They're a guide that allows us to draw the graph. So if we were to graph these, and we might try depending on how time is going, we're going to find these 2 points, negative a0 and a0. Okay, then we'd also find these 2 lines here, and then with that information, then you could draw on your graph, because the graph is going to go really close to that axis, but it's not actually going to touch it. Same thing over here. Once you found this point and you know these 2 lines, the graph is going to go really close to it, but not touch it. Now notice how that equation is from the hyperbola is different than the ellipse. Whoa, hello. Okay, the first big thing is that it's got a plus in between. Okay? So when it's a plus, all of a sudden it changes it. Everything else is the same. Now this picture that you see over here as ellipse is one where the x is first. And so in that one, the semi-major axis or the longer axis is going to be the horizontal one. If, for instance, we had the y first, then it's like it's rotated 90 degrees and it's going to be longer up and down than it is right to left. So a couple of things that you might be able to notice: you've got your semi-major axis, that is going to be the short one, the semi-minor axis, and then the semi-major axis is going to be the longer one. This has 2 focuses or foci, okay, on either side. And we also have our vertex here. And then how weird is that? You got a co-vertex. All these crazy things going on. All right, so the important thing I want you to take from this is the difference between the 2 shapes. And then if you were to look at equation, you may not necessarily know how to graph it right at this moment, but you could at least recognize what shape it or what conic section it is. Is it an ellipse? Is it a hyperbola? Is it a parabola? Or is it a circle? I would hope that you could do that at a minimum. Now for your homework, what I'm asking that you do is that you draw 4 pictures for me. 1 circle, 1 parabola, 1 hyperbola, and 1 ellipse. And then I want you to use your notes to identify some of the important aspects of that graph that we talked about. I just want you to recognize them. I want you to feel comfortable with the terms so that if you see them, it's not going to make you panic or throw you off. It's something that we can work with in the future.